Welcome to the Bedtime Lab, where the mysteries of the universe gently unravel as you rest. I'm delighted to have you here, and tonight we'll be embarking on an extraordinary journey through the cosmos as we explore the fascinating world of solar flares and space weather. I hope you're comfortable and ready to drift into a state of wonder and relaxation. If you'd like, share where you're from in the comments below. It's always lovely to know where our friends are tuning in from around the globe. Let's begin with a question. Have you ever wondered what causes those brilliant displays of northern and southern lights in the sky? Well, it's all tied to solar flares, those magnificent bursts of energy from the sun. The lights you see dancing in the sky, known as auroras, are the result of charged particles from solar flares interacting with Earth's magnetic field. Isn't it amazing how something so far away can create such beauty here on Earth? And here's something fascinating. Solar flares are like gigantic energy explosions, releasing the equivalent energy of millions of 1 megaton nuclear bombs in just a matter of minutes. It's incredible to think about the sheer power contained in these solar events, isn't it? Despite this immense power, the sun is around 150 million kilometers away, so we don't feel the direct impact here on Earth. Speaking of which, did you know that solar flares can also affect our technology? These powerful eruptions can disrupt satellite communications, GPS systems, and even power grids. It's a gentle reminder of how interconnected our world is with the universe. Can you imagine the sun, so far away, having such a profound effect on our daily lives? Here's another intriguing fact. Solar flares are classified into 3 main categories, ranked by their strength. The smallest ones are C-class, the moderate ones are M-class, and the largest are X-class flares. The flares we need to be most concerned about are the X-class, because they have the potential to cause significant disturbances here on Earth. But don't worry, our planet is well equipped to handle these energetic bursts. Take a moment to ponder this. The sun's surface, known as the photosphere, is a seething sea of plasma, and solar flares occur when magnetic energy that has built up in the solar atmosphere is suddenly released. This process is similar to the snapping of a rubber band that has been twisted too tightly. Such a simple comparison for such a grand cosmic event, isn't it? Let's continue our exploration. Solar flares are often associated with sunspots, which are dark patches on the sun's surface. These spots are cooler than the surrounding areas and are signs of intense magnetic activity. The more sunspots present, the more active the sun is, and the more frequent solar flares can become. Did you know that these sunspots have a cycle of their own? They follow an approximately 11-year cycle known as the solar cycle. During the solar maximum, sunspots and solar flares become more frequent. Conversely, during the solar minimum, they become less common. This rhythmic dance of solar activity is something scientists have been observing for centuries. Here's a thought to ponder. Even though solar flares are incredibly powerful, they are not the most energetic events in the universe. That title belongs to gamma-ray bursts, which occur billions of light-years away. Still, the fact that we can witness solar flares with the naked eye through auroras is a testament to their incredible energy. Speaking of energy, did you know that solar flares can travel at speeds of up to 3,000 kilometers per second? That's fast enough to travel from New York to London in less than a second. It's astonishing to consider how quickly these waves of energy can traverse the vastness of space. Here's a delightful tidbit. While we often associate the sun with warmth and light, solar flares remind us of its volatile nature. They are an essential part of the sun's life cycle and help distribute energy throughout the solar system. This balance between beauty and chaos is what makes our universe so captivating. As we meander through these cosmic musings, consider this. The study of space weather, including solar flares, is crucial for protecting our technology and infrastructure. Scientists around the world work tirelessly to monitor the sun's activity, ensuring that we can adapt and respond to any potential disruptions. And here's another intriguing fact. The sun isn't the only star capable of producing solar flares. Our galaxy is filled with stars that can unleash similar bursts of energy, though they may not always have the same impact on their surrounding planets. It's a humbling reminder of the vastness and diversity of the universe. Let's pause for a moment to appreciate the sun as a dynamic and ever-changing entity. Its activity, including solar flares, is a dance of creation and destruction, influencing not only our world but the entire solar system. Yet, despite its immense power, it continues to provide the energy that sustains life on Earth. Isn't it comforting to think that even the most powerful forces of nature can have a gentle side? The sun, with all its fiery activity, also gives us warmth, light, and those enchanting auroras. As we drift into a peaceful slumber tonight, may we carry with us the knowledge that the universe is full of wonders waiting to be discovered. Thank you for joining me on this journey through the Bedtime Lab. Sweet dreams, dear friend. Let me share an intriguing observation. Solar flares, despite their striking power, originate from a process that begins far beneath the sun's surface. These massive energy releases are triggered by the sun's magnetic fields, which twist and tangle as they extend into the solar atmosphere. Imagine the magnetic field lines as invisible threads, intertwining and building tension until, finally, they snap and release their pent-up energy. It's like watching cosmic marionettes perform a dance of fiery unpredictability. And did you know that these flares can influence the weather here on Earth, albeit indirectly? When a solar flare occurs, it can lead to geomagnetic storms in Earth's magnetosphere. These storms, in turn, can cause beautiful auroras, but also have the potential to disrupt radio communications and navigation systems. It's a fascinating example of how intimately connected we are to our star. Here's something you might find surprising. The energy from a solar flare can take as little as 8 minutes to reach Earth, traveling at the speed of light. Yet, the charged particles that accompany these flares, often taking a day or two to arrive, bring with them the potential to create the dazzling auroral displays we so admire. It's a reminder of the sun's dual nature, both a giver of life and a force to be respected. Speaking of the sun's influence, have you ever considered how solar flares can affect astronauts? In space, there is no atmosphere to shield them from radiation. When a significant solar flare occurs, astronauts aboard the International Space Station may need to seek shelter in more shielded areas of the spacecraft to protect themselves from increased radiation levels. The careful planning required for space missions is just another testament to the sun's far-reaching power. Let's think about this. While solar flares can be disruptive, they also have a creative side. The energy they release can interact with the Earth's ozone layer, creating nitrogen oxides that can temporarily alter the chemistry of our atmosphere. This process illustrates the delicate balance maintained by the Earth's systems in response to solar activity. Here's a curious detail. The sun rotates on its axis, much like Earth, but it doesn't spin as a solid body. Instead, different parts of the sun rotate at different speeds. The equator completes a rotation in about 25 Earth days, while the poles take over 30 days. This differential rotation is a key factor in the generation of solar flares, as it contributes to the twisting of magnetic fields. You might find this interesting. During a solar maximum, when solar activity peaks, the frequency of solar flares increases significantly. This heightened activity is not just limited to flares. It also includes coronal mass ejections, which are huge bubbles of gas threaded with magnetic field lines that are ejected from the Sun over several hours. While these events can be disruptive, they are also vital for understanding the Sun's magnetic properties. Let me share another fascinating tidbit. Solar flares are monitored by space weather forecasters using satellites equipped with specialized instruments. These satellites can detect X-rays and ultraviolet radiation emitted by the flares, providing valuable data that helps scientists predict how these events might impact Earth. It's a testament to human ingenuity that we can keep such a vigilant watch on our star from so far away. And here's something else. The study of solar flares and space weather is not a new endeavor. Records of unusual auroral events date back centuries, with ancient cultures often interpreting these phenomena as mystical or divine occurrences. Today, we understand them as the natural result of our planet's interaction with solar energy, yet their beauty and mystery continue to captivate us. Consider this. As our Sun ages, its behavior will continue to evolve. In about 5 billion years, it will exhaust its nuclear fuel and expand into a red giant. During this process, the frequency and intensity of solar flares could change dramatically. While this transformation is far beyond our lifetime, it's a poignant reminder of the Sun's dynamic nature. Let me share a thought-provoking idea. Despite our advances in understanding solar flares, much remains a mystery. The exact mechanisms that trigger these eruptions are still not completely understood, and researchers are continually developing new models to unravel the Sun's secrets. Each discovery brings us closer to comprehending the complexity of our star. Here's a delightful insight. The magnetic fields responsible for solar flares also create sunspots, which have been observed since the days of Galileo. These spots appear dark because they are cooler than the surrounding areas, yet they are still incredibly hot by earthly standards, with temperatures reaching about 4,000 degrees Celsius. It's extraordinary to think how these spots, seemingly small against the vastness of the Sun, play a crucial role in solar activity. And did you know, when viewed through specialized filters, solar flares reveal a kaleidoscope of colors, each representing different wavelengths of light emitted by various elements in the Sun's atmosphere. This spectral analysis allows scientists to study the composition and dynamics of solar flares in exquisite detail, adding to our ever-growing understanding of the Sun. Finally, here's a comforting thought. Despite the Sun's fiery flares and magnetic storms, life on Earth continues, shielded by our atmosphere and magnetic field. It's a beautiful balance, one that allows the Sun to nurture life while we, in turn, study and marvel at its grandeur. As you let these gentle musings settle in your mind, perhaps you'll find a deeper appreciation for the Sun's role in our cosmic story. Speaking of our cosmic story, have you ever thought about how solar flares, though incredibly energetic, are often too faint to be seen with the naked eye from Earth? It's intriguing to consider the immense power of these eruptions, yet they unfold silently in the vastness of space. Our inability to directly observe them without special equipment highlights the many unseen forces that shape our universe. Here's another thought to ponder. Solar flares release energy across the electromagnetic spectrum, including radio waves. This can disrupt radio communications on Earth, particularly in the high-frequency range. So, next time you experience static during a radio broadcast, It could be the sun flexing its magnetic muscles. And here's something mind-boggling. The largest solar flare ever recorded occurred in November 2003, reaching an estimated X28 on the solar flare scale. Such a powerful flare is beyond the typical range, which usually tops out at X10. The sheer magnitude of this eruption demonstrates the potential for extreme space weather events, which remain rare and unpredictable. You might find it fascinating that solar flares often precede or accompany coronal mass ejections, those massive expulsions of solar plasma. When these ejections head towards Earth, they can interact with our magnetic field, creating geomagnetic storms. These storms occasionally induce electric currents in power lines, potentially causing widespread electrical disruptions. Another captivating aspect is the role of sunspots in solar flare activity. Sunspots, with their intense magnetic fields, serve as the birthplace for many flares. The more sunspots present, the higher the likelihood of flare activity. This correlation is part of what scientists use to predict solar cycles and anticipate periods of heightened solar events. Did you know that during intense solar activity, the density of the Earth's atmosphere can increase, causing satellites to experience more drag? This additional atmospheric friction can alter satellite orbits over time, requiring adjustments to maintain their intended paths. Let's dive deeper into the mysteries of space weather. Solar flares can also influence the ionosphere, a region of Earth's upper atmosphere packed with charged particles. When flares increase the density of this layer, radio waves can be absorbed or reflected differently, impacting long-distance communications and navigation systems. It's remarkable how a solar event millions of kilometers away can ripple through our technological infrastructure. Now, consider the delicate ballet of space weather forecasting. Scientists use data from numerous satellites and ground-based observatories to track solar activity. By analyzing this information, they can issue alerts and forecasts, allowing us to prepare for potential impacts. This proactive approach highlights the importance of continuous monitoring and the intricate dance between technology and nature. Here's an intriguing fact about the sun's magnetic field. It flips polarity approximately every 11 years, a process known as the solar cycle. During this time, the sun's north and south magnetic poles switch places, leading to increased solar activity, including more frequent and intense solar flares. These cycles are crucial for understanding long-term patterns in space weather. It's quite fascinating to think about how this regular flipping is a natural part of our star's life. And here's a little-known detail. While solar flares themselves do not pose a direct threat to human health on Earth, their interaction with our planet's magnetic field can, as mentioned earlier, pose radiation risks for astronauts and high-altitude flights near the poles. The precautions taken during solar storms remind us of the delicate balance needed to protect life while exploring the cosmos. Speaking of exploration, it's worth noting that during solar storms, auroras can be seen further from the poles, lighting up the skies in regions unaccustomed to such spectacles. This expansion of auroras is a beautiful reminder of the dynamic dance between our planet and its star. Another captivating phenomenon linked to solar flares is the occurrence of solar proton events. These bursts of solar protons can travel nearly light speed, reaching Earth in a matter of minutes. While our atmosphere shields us from these particles, they can pose significant risks to satellites and astronauts, affecting space missions and requiring vigilant monitoring. Imagine the challenge of planning a space launch around such unpredictable events. Did you know that scientists use sunspot observations to reconstruct historical solar activity? By studying patterns in ancient sunspot records, they can infer past solar cycles and compare them to contemporary data, providing insights into the sun's long-term behavior. And finally, let me leave you with this thought. Despite the challenges posed by solar flares and space weather, they also offer us opportunities to learn more about the universe. Each flare provides a wealth of data, helping us understand the fundamental processes that govern stars not just in our galaxy, but throughout the cosmos. These insights are a testament to humanity's unending curiosity and our ability to adapt and thrive in the face of nature's grandeur. As you drift into a restful slumber, let these gentle reminders of our universe's wonders cradle your dreams, offering solace in the knowledge that we are part of something truly magnificent. Did you know that our sun, despite its constant presence in the sky, is actually a variable star? This means its brightness changes over time, which can influence solar activity, including flares. These fluctuations occur due to the complex interplay of magnetic fields within the sun, which can lead to periods of increased or decreased solar activity. It's fascinating to think that the star we rely on for life is constantly evolving and changing its behavior. Speaking of magnetic fields, the sun's surface is a dynamic tapestry of magnetic activity, with new sunspots and active regions constantly forming and dissipating. This ever-changing landscape is what fuels solar flares, as intense magnetic energy is built up and then suddenly released. Imagine the sun as a celestial conductor, orchestrating an unseen symphony of magnetic forces. Have you ever wondered why solar activity seems to peak and then diminish in a somewhat regular pattern? This is due to the solar cycle, with its average duration of about 11 years, marked by periods of solar maximum and solar minimum. During solar maximum, the sun is teeming with sunspots and active regions, leading to more frequent solar flares. It's a bit like the tides, ebbing and flowing with a rhythm that is both predictable and mysterious. Interestingly, solar flares are classified based on their intensity, using a letter and number combination. The smallest flares are categorized as A-class, followed by B, C, M, and X, with X being the most powerful. Each letter represents a 10-fold increase in energy, so an M-class flare is 10 times more intense than a C-class flare. It's a simple yet effective way for scientists to communicate the scale of these solar outbursts. Have you ever considered what it would be like to witness a solar flare up close? While we can't venture too near, spacecraft such as NASA's Solar Dynamics Observatory capture stunning images and data of these events, allowing us to study them in detail. These missions provide invaluable insights, helping us to decode the sun's inner workings and predict future solar activity more accurately. Here's a curious thought. Solar flares can also produce something called solar energetic particles, or SEPs. These are high-energy particles that travel through space and can have significant effects on satellites and astronauts. The acceleration of these particles is still not fully understood, making them a key area of study for scientists trying to unlock the secrets of space weather. And did you know that the sun's influence extends far beyond our solar system? Our star generates a protective bubble known as the heliosphere, which shields the planets from cosmic radiation. During periods of heightened solar activity, this bubble can expand or contract, affecting how much cosmic radiation reaches Earth. It's a reminder of how interconnected the cosmos really is, with the sun playing a crucial role in maintaining the delicate balance of our solar neighborhood. Speaking of cosmic connections, solar flares also contribute to the phenomenon known as space weather. This term encompasses not only solar flares but also the broader impacts of solar activity on the space environment. Space weather can affect everything from satellite operations to astronaut safety to the reliability of our communication networks. It's a field that requires constant vigilance and innovation to mitigate potential disruptions. Did you know that during powerful solar flares, the sun can release as much energy in a few minutes as 1 billion hydrogen bombs? This staggering amount of energy is a testament to the sun's power and the intricate processes happening within its core. It serves as a humbling reminder of the forces at play in the universe and our small yet significant place within it. Here's a fascinating tidbit. The study of solar flares and space weather is a truly global effort, with scientists around the world working together to monitor and understand these phenomena. This collaboration helps us develop better predictive models and innovative technologies to protect our planet and its inhabitants. It's a beautiful example of the collective human spirit, united by a shared curiosity and a desire to explore the cosmos. Have you ever thought about the impact of solar flares on our daily lives? While most of us are not directly affected, the technology we rely on is highly susceptible. For example, GPS signals can be disrupted by solar activity, affecting everything from navigation systems to financial transactions. It's a reminder of how deeply interconnected our modern world has become with the forces of nature. Here's something captivating. Scientists have discovered that the sun emits a constant stream of charged particles known as the solar wind. This wind interacts with Earth's magnetic field, creating a protective barrier against harmful cosmic radiation. During periods of intense solar activity, the solar wind can strengthen, providing additional shielding but also increasing the likelihood of geomagnetic storms. Did you know that the study of sunspots and solar activity dates back to ancient civilizations? Early astronomers observed sunspots with the naked eye and recorded their appearances, laying the groundwork for our modern understanding of solar cycles. It's inspiring to think about the long history of human curiosity and our enduring quest to understand the universe. Lastly, consider this. Despite the challenges posed by solar flares and unpredictable space weather, they serve as a powerful reminder of our sun's dynamic nature. Each flare and storm offers a glimpse into the mysteries of our star, providing us with opportunities to learn and adapt. As you drift into slumber, let the wonders of the cosmos fill your dreams, offering a peaceful journey through the vastness of space. As we continue our journey through the mysteries of solar flares and space weather, let me share something intriguing. Solar flares can have a mesmerizing visual impact here on Earth, manifesting as the auroras. These stunning displays of light, often referred to as the northern and southern lights, are caused by charged particles from the sun colliding with molecules in Earth's atmosphere. Isn't it fascinating how a distant event on the sun can create such beauty in our night skies? Speaking of light displays, did you know that not all solar flares are visible to the naked eye? Some flares emit radiation beyond the visible spectrum, like ultraviolet and X-ray light. These invisible flares are just as potent and can affect Earth's upper atmosphere by disrupting radio communications, illustrating the far-reaching influence of solar activity. Now, here's a thought-provoking fact. The sun's magnetic field is responsible for the formation of sunspots, which are cooler, darker regions on the sun's surface. These spots are often precursors to solar flares, as the intense magnetic activity around them can cause the sun's magnetic field lines to twist and snap, releasing vast amounts of energy. It's a powerful reminder of the sun's dynamic and ever-changing nature. You might find it surprising that solar flares can impact our planet's atmosphere in subtle yet significant ways. During a solar flare, The increased radiation can cause the Earth's ionosphere to expand. This change can alter the paths of radio waves used for communication and navigation, highlighting the sun's ability to influence our technological systems. Here's another captivating insight. The sun isn't the only star to experience solar flares. Our universe is filled with stars that exhibit similar activity, each with their unique characteristics. By studying solar flares on these distant stars, astronomers can better understand the life cycles and behaviors of stars across the cosmos, broadening our understanding of stellar dynamics. Consider this: solar flares can influence space weather on other planets in our solar system as well. For instance, Mars lacks a global magnetic field like Earth's, making it particularly vulnerable to solar storms. These storms can strip away Mars's atmosphere over time, shedding light on the planet's past and its climate history. It's a sobering reminder of how essential Earth's magnetic field is to our planet's protection. Here's a fascinating concept to ponder. The study of solar flares and space weather is essential for planning future space missions, especially those that involve human travel to the Moon, Mars, or beyond. Understanding the timing and intensity of solar activity is crucial for the safety of astronauts, who rely on this information to avoid harmful radiation exposure in space. Did you know that solar activity can even have an effect on Earth's weather? Although the sun's influence is just one factor among many, during periods of high solar activity, there is a slight increase in global temperatures. This is due to the extra energy and particles reaching our planet, demonstrating how interconnected the cosmic and terrestrial realms truly are. Here's something intriguing. Scientists use solar flares to study the sun's interior. By analyzing the seismic waves produced by flares, researchers can gain insights into the sun's inner layers and their properties. This field, known as helioseismology, is a bit like using an ultrasound to peer inside the sun, unveiling the hidden processes that drive solar activity. Consider the delicate balance within our solar system. The sun's gravitational pull, combined with solar flares and the solar wind, plays a role in shaping the orbits of comets and asteroids. These small celestial bodies are often nudged closer or farther from the sun, ultimately impacting their journeys and potential encounters with Earth. Did you know that ancient cultures had unique interpretations of solar flares and sunspots? Some saw them as omens or divine messages, while others incorporated them into myths and legends. These interpretations, while not scientifically accurate, reflect humanity's enduring fascination with the sun and its behaviors, bridging the gap between ancient wisdom and modern science. It's incredible to think how far technology has come in helping us understand solar flares. Instruments on spacecraft like the Parker Solar Probe and the Solar and Heliospheric Observatory provide real-time data, enabling scientists to observe solar activity as it happens. This continuous stream of information is vital for predicting space weather and protecting our technological infrastructure. Speaking of technological advancements, have you considered how solar flares impact the burgeoning field of space tourism? As private companies venture into space travel, understanding solar activity becomes increasingly important. Ensuring the safety of passengers and spacecraft during periods of heightened solar activity is crucial for the industry's success and the future of human exploration. Now, let me share a poetic notion. Each solar flare, with its explosion of energy and light, is a reminder of the sun's vitality and the ancient forces that govern our universe. These flares, while sometimes disruptive, are also a testament to the sun's role as a life giver, providing the energy that sustains life on Earth. As you reflect on these cosmic wonders, let the gentle rhythms of the universe lull you into a serene, restful state, embracing the night with curiosity and peace. The dance of solar flares within our solar system is a continuous source of wonder, with each flare telling a unique story of energy and transformation. Imagine this. Solar flares can travel from the Sun to Earth in a matter of minutes, with the speed of charged particles reaching up to 2,000 kilometers per second. This rapid journey through space highlights the Sun's dynamic power, reaching across millions of kilometers to impact our planet. It's intriguing to think that solar flares can cause beautiful and eerie phenomena known as whistlers in the Earth's atmosphere. These are radio waves that travel along magnetic field lines from one hemisphere to the other, creating sounds reminiscent of a descending whistle. Such atmospheric music is a testament to the interconnectedness of space weather and our planet's magnetic field. Did you know that not all solar flares are created equal? They are categorized by their intensity into classes such as A, B, C, M, and X, with X being the most intense. These categories help scientists predict the potential impact of a flare on Earth, from minor disturbances to significant disruptions. This classification system is akin to predicting storms on Earth, allowing us to prepare for the sun's tempers. Here's an interesting tidbit. During intense solar storms, the high-energy particles released can cause malfunctions in satellite electronics. Satellites are critical for everything from GPS to television broadcasting, and their resilience is constantly improved to withstand these cosmic challenges. It's fascinating how our technology must adapt to the whims of the sun. On a more personal note, did you know that solar activity can subtly influence human health? Some studies suggest that fluctuations in geomagnetic activity, which can be triggered by solar flares, might affect human biological rhythms, sleep patterns, and even mood. While the effects are subtle, they remind us of our deep connection to the cosmos. You might find it surprising that auroras, the beautiful light shows in polar regions, are not just an earthly phenomenon. Similar displays have been observed on other planets, such as Jupiter and Saturn, where they are caused by the interaction of solar winds with the planet's magnetic fields. These celestial lights demonstrate the universal nature of space weather across the solar system. Speaking of universality, consider this. The energy released by a single solar flare can be equivalent to millions of nuclear bombs detonating simultaneously. Yet, this immense energy is a natural and regular part of the sun's activity, showcasing the incredible forces at play within our star. Let me share another captivating fact. Solar flares, although powerful, are just one aspect of the sun's influence. The solar wind, a continuous stream of charged particles emitted by the sun, shapes the entire heliosphere, which is the vast bubble-like region of space dominated by the sun's influence. This solar wind creates the boundary between our solar system and interstellar space, guiding cosmic rays and affecting space weather far beyond Earth. It's fascinating to realize that solar flares can also impact the Earth's magnetic field, causing what are known as geomagnetic storms. These storms can increase the drag on satellites, causing them to shift in their orbits, and can even induce currents in power lines, leading to potential electrical grid failures. Our modern world is intricately linked to the sun's temperament. Here's a surprising notion. During periods of solar maximum, when solar activity is at its peak, the number of sunspots increases significantly. These dark patches are cooler areas on the sun's surface, and their presence indicates heightened solar activity. Observing these patterns helps scientists anticipate the sun's behavior and prepare for future space weather events. Speaking of preparation, did you know that scientists use sophisticated computer models to simulate and predict solar flares and their subsequent effects? These models are informed by data from observatories and spacecraft, providing crucial insights into the potential paths and impacts of solar phenomena. It's a blend of technology and science that helps protect our planet and its technological systems. Consider this intriguing thought. The sun's activity has influenced human history in subtle yet profound ways. For instance, the Maunder minimum, a period of low solar activity in the late 17th century, coincided with the Little Ice Age, a time of cooler temperatures in Europe and North America. This historical link between solar behavior and climate reminds us of the sun's far-reaching influence on our world. And here's a delightful detail. The study of solar flares not only advances our understanding of the sun, but also inspires art and culture. Artists, musicians, and writers have long drawn inspiration from the sun's fiery displays, using them as metaphors and motifs in their work. The sun's radiant energy continues to fuel human creativity and imagination. As we contemplate these solar wonders, we are reminded of the delicate balance that sustains life on Earth. The sun nurtures and challenges us. Its flares a constant reminder of its ancient, untamed power. With each flare, we are drawn closer to the mysteries of the cosmos, inviting us to dream of the infinite possibilities that lie beyond our world. Let these thoughts guide you gently into the embrace of the night, where dreams and reality entwine in the quietude of sleep. The sun, with its vibrant energy, influences the Earth in ways that often go unnoticed in our daily lives. For instance, did you know that solar flares can sometimes lead to a phenomenon called auroral substorms? These substorms are bursts of energy in the Earth's magnetosphere that intensify the auroras, creating spectacular displays of light in the night sky. It's as if the sun and Earth engage in a celestial dance, painting the heavens with vibrant colors. Now, shifting our attention a bit, here's something intriguing. The sun's activity follows an approximately 11-year cycle known as the solar cycle, during which the frequency of solar flares and sunspots waxes and wanes. This rhythmic pattern is essential for predicting when solar storms are more likely to occur. Imagine the sun as a pulsating heart, each beat influencing the cosmic environment in which our planet resides. Speaking of patterns, did you ever wonder why astronauts need to be careful during solar flares? The high-energy particles emitted during these events can pose a significant risk to their health, increasing exposure to radiation. Space agencies closely monitor solar activity to ensure the safety of those venturing beyond Earth's protective atmosphere. In a sense, astronauts become intimately attuned to the sun's moods, adapting their activities to the rhythms of space weather. And here's a curious fact: solar flares are not just a modern concern. Historical records show that ancient Chinese astronomers observed sunspots, sometimes linking them to unusual weather patterns on Earth. These early observations were among the first steps toward understanding the sun's influence on our planet. It's fascinating to think that even in antiquity, there was an awareness of the sun's dynamic nature. On the subject of historical influences, consider this. The Carrington event of 1859 was the most powerful geomagnetic storm on record, caused by an intense solar flare. This event was so potent that it set telegraph lines on fire and created auroras visible as far south as the Caribbean. Such dramatic solar activity serves as a reminder of the sun's ability to affect human technology and infrastructure on a grand scale. Let me share something truly remarkable. The sun's influence extends beyond our own solar system. Its heliosphere acts as a protective shield, deflecting cosmic radiation and interstellar particles that constantly bombard our galaxy. This protective bubble is shaped and maintained by the solar wind, illustrating how the sun's reach envelops our entire cosmic neighborhood. Speaking of the sun's reach, did you know that solar flares can also impact the ionosphere, a layer of the Earth's atmosphere that reflects radio waves? Increased solar activity can cause disruptions in radio communications and navigation systems, highlighting the sun's ability to influence technology on Earth. It's as if the sun's whispers can sometimes become thunderous roars, reaching down to touch the Earth in unexpected ways. Here's a thought-provoking detail. During solar minimum, when the sun is least active, the Earth's upper atmosphere cools and contracts. This leads to reduced atmospheric drag on satellites, slightly extending their operational lifetimes. It's a quiet period of respite, where the sun's calm grace allows for a breather in the relentless pace of orbital mechanics. Have you ever considered the role of solar flares in scientific research? These events provide invaluable opportunities to study the sun's magnetic field and plasma processes, offering insights into the fundamental physics of our universe. Each flare is like a natural laboratory where scientists can observe and learn about the fundamental forces that govern our solar system. As we ponder these connections, here's a delightful notion. The study of solar flares has sparked a renewed interest in space weather forecasting. Just as meteorologists predict terrestrial weather, scientists are developing models to forecast space weather, helping to mitigate the effects of solar storms on satellites, power grids, and communication networks. It's a testament to human ingenuity and our ability to adapt to the challenges posed by the sun. And speaking of adaptability, did you know that solar flares have been considered as potential energy sources for future space missions? The idea is to harness the energy released during flares to power spacecraft, potentially revolutionizing space travel. It's a visionary concept that underscores our quest to harness the sun's power for the benefit of exploration and discovery. In reflecting on these solar phenomena, consider the sun's dual nature, a source of warmth and light, yet also a beacon of cosmic power. Each flare reminds us of the sun's role as both a life-giving star and a force of nature that must be respected. It's a balance that mirrors the delicate equilibrium of life itself, a perpetual cycle of creation and transformation. As you close your eyes and drift into the peaceful realm of sleep, let the wonders of the sun guide your dreams. Imagine the auroras dancing across the night sky, the rhythmic pulse of the solar cycle, and the vast heliosphere protecting our tiny planet. These cosmic elements weave together, nurturing our world and inspiring our dreams of the universe. As you rest, remember that the sun's quiet lullaby continues, a gentle reminder of our place in the cosmos. As we continue our celestial journey, let me share with you an intriguing element of solar flares. They are classified by their intensity into categories, with the most powerful being the X-class flares. These flares can unleash energy equivalent to millions of hydrogen bombs, illustrating just how formidable the sun's eruptions can be. Imagine that power radiating across space, its effects felt millions of miles away on Earth. Here's something that might surprise you. Solar flares are often accompanied by coronal mass ejections, or CMEs, which are massive bursts of solar wind and magnetic fields rising above the solar corona. When these CMEs are directed towards Earth, they can trigger geomagnetic storms, influencing everything from satellite operations to power grids. It's like the sun sending a powerful breath across the vastness of space. Speaking of unexpected, did you know that solar flares can actually affect the migratory patterns of animals? Birds, fish, and even some mammals are believed to use Earth's magnetic field for navigation. When solar activity disturbs this field, it can cause these creatures to lose their way, reminding us of the intricate connections between our planet and the Sun's dynamic behavior. Consider this fascinating fact. Solar flares release energy across the electromagnetic spectrum, from radio waves to gamma rays. This broad range of emissions allows scientists to study the Sun through various wavelengths, each revealing different aspects of solar processes. It's as if the Sun is a symphony, each note a different frequency of light that harmonizes to create a fuller understanding of our star. And here's a curious thought. During intense solar storms, the auroras can become so bright that they are visible during the daytime. These rare occurrences turn the skies into a canvas of swirling colors, a vivid reminder of the beauty and power of the cosmos. It's no wonder that these natural light shows have inspired myths and legends throughout human history. On the topic of history, did you know that solar flares have been recorded in ancient texts dating back thousands of years? Cultures around the world have documented unusual celestial phenomena, often linking them to significant events on Earth. These early records provide a glimpse into the enduring human fascination with the Sun and its influence on our lives. Let me tell you about an interesting connection. Solar flares can lead to increased incidences of auroral radio absorption, which can interfere with communication systems. This phenomenon is especially relevant for regions close to the poles, where auroras are most frequent. It's a reminder of the delicate balance we maintain with the forces of nature, adapting our technology to coexist with the Sun's vibrant dance. Here's a thought-provoking notion. The study of solar flares has led to advancements in understanding space weather, which encompasses not just solar activity, but also the conditions in space caused by the Sun's behavior. This field of research seeks to safeguard our technology and infrastructure, highlighting the intersection of natural phenomena and human ingenuity. Have you ever wondered about the impact of solar flares on the human body? While we are largely protected by Earth's atmosphere and magnetic field, astronauts in space are more vulnerable. Prolonged exposure to solar radiation can increase the risk of cancer and other health issues, necessitating careful monitoring and protective measures during space missions. Speaking of space missions, did you know that some spacecraft are designed to withstand solar storms by going dormant? By entering a low-power mode, these spacecraft can minimize damage from the increased radiation and charged particles, ensuring their longevity and continued function. It's an ingenious approach to safeguarding our exploratory tools in the harsh environment of space. Here's a delightful tidbit. Solar flares can influence the composition of the upper atmosphere by ionizing atoms and molecules. This ionization process can lead to changes in atmospheric chemistry, affecting everything from climate patterns to the propagation of radio signals. It's another example of how the Sun's energy permeates our world, shaping the very air we breathe. As we ponder these connections, consider this. The study of solar flares has spurred technological innovation in Earth-based observational tools. Advanced telescopes and satellites now provide detailed imagery of solar activity, allowing scientists to monitor and predict solar flares with unprecedented accuracy. This progress underscores our evolving relationship with the Sun as we strive to understand and harness its power. And here's a final intriguing fact for tonight. Researchers are exploring the possibility of using solar flare data to develop new methods of predicting earthquakes. While the science is still in its infancy, The idea is that geomagnetic disturbances caused by solar activity could correlate with seismic events on Earth. It's a testament to the interconnectedness of all things, from the depths of the Earth to the farthest reaches of space. As you let these wondrous insights drift through your mind, imagine the sun as a silent guardian, its flares a reminder of the vibrant universe we are part of. Each piece of knowledge is like a star in the vast night sky, illuminating the path of discovery and understanding in the universe. As you relax, know that the mysteries of the cosmos are an ever-present lullaby, weaving dreams of endless exploration and awe. As you find yourself enveloped in the gentle rhythms of the universe, let me share another captivating facet of solar flares. Did you know that the sun's activity follows an approximate 11-year cycle known as the solar cycle? During this period, the frequency and intensity of solar flares and sunspots wax and wane. It's like a heartbeat of the sun, a natural rhythm that astronomers have observed and studied to understand the sun's moods. Speaking of rhythms, here's a fascinating concept to ponder. Solar flares can travel at astonishing speeds, with some reaching Earth in as little as 8 minutes. Imagine that. Energy unleashed from the sun reaching across the 93 million miles to influence our planet in less time than it takes to brew a cup of tea. This speed underscores the immense power and connectivity of our solar system. And did you ever wonder about the sound of a solar flare? While sound doesn't travel through the vacuum of space, scientists have converted solar data into sound waves, creating eerie symphonies that reflect the sun's turbulent surface. Listening to these sounds offers a unique way to experience the energy and movement that is otherwise invisible and silent to us. In another twist of interstellar interaction, solar flares can spark beautiful and sometimes mysterious phenomena on Earth's surface. For example, did you know that intense auroras caused by solar flares can sometimes interfere with wildlife, affecting the behavior of animals sensitive to magnetic changes? These creatures, often in polar regions, might find themselves confused under aurora's mesmerizing glow. Here's an unexpected effect of solar flares. They can impact airline flights, particularly those over polar routes. When solar storms occur, airlines may need to reroute flights to avoid increased radiation levels that could affect both passengers and onboard electronics. This precautionary measure highlights the far-reaching influence of space weather on our daily activities. Speaking of influence, consider this. Solar flares have a surprising impact on global navigation systems. The charged particles released during these events can lead to inaccurate GPS readings, affecting everything from car navigation systems to shipping and aviation logistics. It's a reminder of our reliance on technology and our ongoing dance with the sun's dynamic nature. Have you ever heard of the Carrington event of 1859? This notorious solar storm was so powerful that it caused telegraph systems worldwide to fail. With sparks flying from telegraph machines, it remains the most intense geomagnetic storm on record, a historical benchmark for the potential impact of solar flares on modern technology. And here's something to marvel at. Solar flares can sometimes create what is known as a proton storm. These storms, filled with high-energy particles, pose a significant threat to astronauts and spacecraft outside the protective embrace of Earth's atmosphere. They serve as a stark reminder of the challenges faced by humanity as we reach further into the cosmos. On a more earthly note, did you know that solar flares can enhance the visibility of the aurora australis, the southern counterpart to the aurora borealis? During intense solar activity, the southern lights can be seen much farther north than usual, painting the skies over places like Australia and New Zealand in vivid, dancing hues. Here's a lesser-known fact. Solar flares can affect the chemical composition of the Earth's upper atmosphere. This can influence ozone levels and even have subtle effects on climate patterns. While these changes are typically not immediate or drastic, they illustrate the complex interplay between our planet and the solar environment. In a surprising twist of solar physics, some solar flares are accompanied by what are known as solar quakes. These are seismic-like waves on the sun's surface, resembling ripples on a pond after a stone is thrown. Capturing these waves has provided scientists with insights into the sun's internal structure, much like how earthquakes help geologists study Earth's interior. And let's ponder the future. Researchers are actively exploring ways to harness the immense energy of solar flares. While we are far from achieving this goal, the potential to tap into such a powerful energy source is an exciting prospect that could revolutionize our approach to energy on Earth. Did you know that monitoring solar flares can also be a tool for understanding other stars? By studying similar phenomena in distant stars, astronomers can draw parallels and enhance our knowledge of stellar life cycles and behaviors. Finally, the study of solar flares has led to an intriguing possibility in the quest for extraterrestrial life. Scientists theorize that the interaction of solar particles with the atmospheres of distant planets might create conditions conducive to life, or at least affect the potential habitability of those worlds. It's a thought that stretches the imagination and invites dreams of what lies beyond our solar neighborhood. As you drift along this river of cosmic wonders, let these stories of solar flares and space weather settle gently into your thoughts. Each fact is like a golden thread, weaving a tapestry of understanding and curiosity that spans the skies above. The universe, vast and intricate, whispers its secrets softly, inviting us to listen and learn even as we close our eyes for a night's rest. Let me share something intriguing with you. The sun, with its seemingly constant glow, actually undergoes an 11-year cycle of activity known as the solar cycle. During this cycle, the frequency and intensity of solar flares can vary dramatically. At the peak of this cycle, known as the solar maximum, the sun is particularly active, producing more frequent and intense flares. This rhythmic waxing and waning of solar activity dances to a cosmic tune that has fascinated scientists for years. Now, consider the vastness of the space weather that accompanies these flares. When a solar flare erupts, it can trigger what's known as a coronal mass ejection, or CME. This phenomenon involves a significant release of plasma and magnetic fields from the sun's corona. The sheer magnitude of these ejections is astounding, with billions of tons of solar material being hurled into space at speeds over 1 million kilometers per hour. Speaking of speed, solar flares don't just remind us of interstellar velocities, they also bring light to the concept of space weather forecasting. Did you know that scientists have developed ways to predict solar flares using satellite data and computer models? These forecasts are crucial for preparing and protecting our technology and infrastructure from the impacts of solar storms. And here's something that might surprise you. Solar flares can influence the Earth's ionosphere, a layer of the atmosphere crucial for radio communication. When a flare occurs, it can enhance ionization in this region, leading to disruptions in radio signals. This effect is especially noticeable in high-frequency communication systems, which can experience temporary blackouts as a result. The interaction between solar flares and our planet doesn't stop there. Have you ever imagined that these flares could impact our climate? While their effect is not direct, the energy released can alter atmospheric circulation patterns, influencing weather conditions. However, these changes are often subtle and long-term, blending into the complex tapestry of Earth's climate system. Turning our gaze back to space, solar flares are not only a terrestrial concern, they also pose risks to space missions and satellites. The charged particles from flares can damage sensitive electronics aboard spacecraft, making it essential for mission planners to account for space weather in their designs and operations. It's a reminder of the delicate balance required to explore beyond our earthly confines. Now, let's delve into the interactions of solar flares with other celestial bodies. For instance, did you know that Jupiter's intense magnetic field can actually funnel solar particles towards its poles, creating auroral displays similar to Earth's? These Jovian auroras are much larger and more powerful, offering a spectacular glimpse into the interplay between solar and planetary forces in our solar system. Have you ever thought about how solar flares can affect even the simplest of life's pleasures, like watching a meteor shower? Increased solar activity can heighten the visibility of meteors as more particles enter the Earth's atmosphere, burning up and creating beautiful streaks of light across the night sky. It's a celestial performance orchestrated by the sun's fiery temperament. Speaking of performances, solar flares have inspired art and culture throughout human history. The stunning auroras, a direct manifestation of solar storms, have been depicted in countless works of art and literature, serving as a muse for generations. These natural light shows remind us of our intrinsic connection to the cosmos and its influence on our creativity. Here's a whimsical thought. Solar flares can even influence the length of our day. Although the effect is minuscule and not perceptible in daily life, the energy and momentum transferred from solar activity can cause tiny fluctuations in the Earth's rotation speed. It's a testament to the intricate ways in which our planet and the Sun are intertwined. And as we continue to explore the effects of solar flares, have you ever wondered about their role in the broader universe? Solar flares are not unique to our Sun. They occur on stars throughout the galaxy, each event a dazzling burst of energy that contributes to the dynamic nature of the cosmos. By studying these stellar flares, astronomers gain insights into the life cycles and behaviors of distant stars. In the realm of scientific research, solar flares are unlocking new frontiers in understanding magnetic fields and plasma physics. These fiery outbursts provide a natural laboratory for studying how magnetic fields can store and suddenly release vast amounts of energy, a process that remains a tantalizing mystery. Here's a curious fact. Some scientists theorize that solar flares could have played a role in the origin of life on Earth. The energy and particles from early solar activity may have contributed to creating the conditions necessary for life to emerge, seeding the primordial soup from which life eventually arose. Finally, let your thoughts drift to the potential of solar flares as a source of inspiration for future technology. The mechanisms behind these powerful explosions could one day inform the development of advanced energy systems on Earth. Imagine harnessing the sun's flares to provide clean, sustainable energy for generations to come. As you ponder these remarkable facts, let the gentle hum of the universe's mysteries lull you into a peaceful slumber. Each revelation is a star twinkling in the vast sky of knowledge, guiding us through the cosmic night. With every heartbeat of the sun, we are reminded of our place within this grand symphony of celestial wonders. Let's take a moment to consider the vibrant dance of charged particles that solar flares unleash. Did you know that these particles can travel all the way to the outer limits of our solar system? Indeed, the Voyager spacecraft, which are now traversing interstellar space, have detected changes in particle density linked to solar activity. It's fascinating to think that the sun's influence reaches so far beyond the planets we know. Speaking of distances, have you ever wondered how far a solar flare's light travels? The light from a flare takes approximately 8 minutes to reach Earth, but its effects can resonate over much longer periods, shaping space weather in ways we are still striving to fully understand. Here's another intriguing thought. Solar flares can actually affect the power grid here on Earth. During intense solar storms, induced currents can flow through power lines, potentially leading to voltage disruptions or even blackouts. Imagine the sun's fiery breath causing lights to flicker on our planet. It's a gentle reminder of the interconnectedness of our solar system. And while we're on the topic of connectivity, did you know that solar flares can also influence the trajectory of spacecraft? The additional drag from increased atmospheric density during solar activity can alter satellite orbits, requiring adjustments to keep them on course. Let me share something else you might find surprising. Solar flares can impact animal navigation. Some migratory species, such as birds and sea turtles, use the Earth's magnetic field to find their way. When solar flares disturb this field, it can cause disorientation, adding an extra challenge to their incredible journeys. This connection between cosmic and terrestrial navigation showcases the delicate balance of life on Earth. And speaking of balance, solar flares also play a role in the chemistry of the upper atmosphere. The energetic particles from flares can initiate reactions that produce nitric oxide, which in turn affects the ozone layer. It's a subtle interplay that underscores the sun's role in maintaining Earth's habitability. In the realm of human health, solar flares have an unexpected impact. High-altitude flights, particularly those near the poles, can expose passengers and crew to increased levels of radiation during solar storms. Airlines sometimes reroute flights to avoid these areas when forecasts predict heightened solar activity, ensuring the safety of those aboard. This precaution is a testament to the practical implications of space weather research. And, on a lighter note, did you ever think about how solar flares influence auroral tourism? These natural light shows become even more spectacular during periods of intense solar activity, drawing more visitors eager to witness the celestial dance. It's an opportunity for people to connect with the cosmos in a beautifully tangible way. Have you ever considered how solar flares might shape technology of the future? Advances in artificial intelligence and machine learning are being harnessed to improve solar flare prediction. By analyzing vast amounts of data from the sun, these technologies are helping to refine our understanding and forecasting of solar weather, paving the way for innovations that safeguard our technological world. And while technology races ahead, solar flares also remind us of our ancient relationship with the heavens. Historically, changes in the sun were believed to be omens, influencing everything from crop yields to the rise and fall of empires. Today, we can appreciate these solar phenomena with scientific wonder rather than superstition, yet their influence remains profound. Turning our gaze outward once more, it's fascinating to note that solar flares have been detected on stars. These stellar flares can be millions of times more powerful than those on the sun, offering a glimpse into the extreme conditions of more distant worlds. Studying these events not only enhances our understanding of solar physics, but also informs the search for habitable exoplanets. After all, a planet's ability to sustain life might depend significantly on the activity of its host star. This exploration of distant solar flares is a reminder of the broader canvas on which our solar system is painted. And here's a whimsical notion to ponder. Solar flares have inspired scientific fiction and fantasy, igniting the imaginations of writers and creators. The idea of harnessing, or being affected by solar storms is a recurring theme in literature and film, a testament to the enduring allure of these fiery phenomena. It is as if the sun's dynamic nature reaches not only into the physical realms of space, but also into the creative depths of the human spirit. As we drift on this sea of cosmic wonders, each fact about solar flares serves as a gentle beacon, guiding us through the vast night sky of knowledge. May these reflections on our brilliant star gently illuminate your dreams and awaken your curiosity, even as you rest. Have you ever marveled at how solar flares, despite their ferocity, can actually help us understand Earth's past climate? Scientists have discovered that cosmic rays, which are influenced by solar activity, can create isotopes like carbon-14 when they interact with the atmosphere. These isotopes get trapped in tree rings and ice cores, providing a record of solar activity over millennia. By studying these records, researchers can gain insights into historical climate patterns and solar cycles. Imagine the stories that ancient trees and deep ice layers can tell us about our star's history. Here's another captivating thought. Solar flares have the power to transform the landscape of radio communication. During intense solar activity, the increased ionization in the Earth's atmosphere can lead to radio blackouts, particularly affecting high-frequency signals. These disruptions can impact everything from military operations to amateur radio enthusiasts, reminding us of the sun's far-reaching influence on our technology-dependent society. It's fascinating to consider how ancient sailors once navigated by the stars, while today our modern star can momentarily silence our communication networks. Speaking of communications, did you know that solar flares can even affect GPS systems? The accuracy of satellite-based navigation can be compromised during solar storms due to changes in the ionosphere, which can alter the speed and path of the signals traveling through it. This can lead to errors in positioning, a significant challenge for industries reliant on precise location data. Next time you check your GPS, consider the sun's invisible hand shaping your route. And here's something that might surprise you. Solar flares are responsible for subtle yet beautiful phenomena known as air glow. Unlike the dazzling auroras, air glow is a faint emission of light caused by the interaction of solar radiation with atmospheric gases, visible from space and sometimes from the ground under ideal conditions. It's a gentle luminescence, painting the night sky with soft hues, a reminder of the sun's quiet artistry. Speaking of artistry, let's delve into the intriguing relationship between solar activity and our planet's natural archive. The sun's cycles can influence the formation of cave formations known as speleothems, like stalactites and stalagmites. Changes in solar activity affect rainfall patterns, which in turn impact the growth of these mineral formations. By studying them, scientists can trace back historical solar cycles and their environmental effects, offering a window into climate changes over thousands of years. Have you ever wondered how solar flares might affect future space missions? The radiation from solar flares poses a significant challenge for human space travel, especially for missions beyond Earth's protective magnetic field, such as journeys to Mars. Shielding astronauts from this radiation is a critical concern, pushing scientists to innovate with new materials and technologies to ensure the safety of our explorers. This quest to conquer space reflects our resilience and ingenuity in the face of cosmic challenges. And let me share something intriguing about the sun's behavior. Solar flares are often accompanied by coronal mass ejections, or CMEs, enormous bursts of solar wind and magnetic fields. While flares can affect the Earth in minutes, CMEs take 1 to 3 days to reach our planet. These events can have more lasting impacts, causing geomagnetic storms that affect power grids and communication systems. The interplay between flares and CMEs highlights the dynamic complexity of our sun's activity. On the topic of complexity, have you ever thought about how solar flares contribute to the mysterious phenomenon known as space weather forecasting? By observing the sun's surface with advanced telescopes and satellites, scientists can predict solar flares and CMEs, providing early warnings to protect our technological infrastructure. This field of study is continually evolving, employing sophisticated models to anticipate the sun's next moves, a celestial weather report keeping us prepared for cosmic surprises. Speaking of surprises, did you know that solar flares can play a role in the behavior of our planet's magnetic field? These flares can trigger geomagnetic storms that temporarily alter the magnetic field, a phenomenon that can affect compasses and even animal migration. The sun's influence on Earth's magnetism is a dance of energy across space, a cosmic tug-of-war that underscores the interconnectedness of our solar system. And here's something to ponder. Solar flares are not just a modern interest, but have fascinated humanity for centuries. The earliest recorded observation of a sunspot, a precursor to solar flares, dates back to Chinese astronomers more than 2,000 years ago. These early sky watchers noted changes in the sun with wonder and reverence, a tradition that continues as we strive to unlock the secrets of our nearest star. In this dance of discovery, solar flares remind us of the profound impact our sun has on life and technology. From shaping the skies with auroras and airglow to influencing future space travel and historical climate patterns, the sun's flares are a testament to the vibrant energy at the heart of our solar system. As we delve into these mysteries, may this journey through solar wonders gently guide you to a place of restful curiosity where the universe whispers its secrets softly as you drift into dreams. Let me share with you a curious detail about solar flares that you might not expect. They can actually produce sound waves. But before you imagine hearing a solar symphony, it's important to know that these are not sounds we can hear on Earth. These sound waves are trapped within the sun's magnetic loops, creating a sort of solar music that plays out in the sun's atmosphere. It's a fascinating reminder of the sun's dynamic nature, where even the power of sound is harnessed in the heart of our solar system. And here's something intriguing about solar flares. They have a peculiar connection with the phenomenon known as backscatter. When solar flares hit the upper atmosphere, they can cause particles to scatter back to their source. This backscattering effect is crucial for understanding how solar radiation affects our planet, as it plays a significant role in altering the chemical composition of the Earth's upper atmosphere. Imagine these tiny particles making a round trip from the sun to Earth and back again, a cosmic commute of sorts. Speaking of cosmic commutes, did you know that solar flares can accelerate particles to nearly the speed of light? These solar energetic particles, as they're known, are among the fastest objects in our solar system. They travel through space, influencing everything from satellite operations to the safety of astronauts. Imagine the sheer power required to propel these tiny particles at such incredible speeds, a testament to the sun's immense energy. On the subject of speed, have you ever considered how quickly solar storms can disrupt communications on Earth? A solar flare can send its effects racing towards us at a mind-boggling pace, sometimes in as little as 8 minutes. The sun's energy travels across the vastness of space to reach us, highlighting how interconnected our world is with the cosmos. It's a reminder that while we may feel distant from the sun, its influence is never far away. Now, here's a fact that might surprise you. Solar flares can influence the behavior of lightning on Earth. Some studies suggest that solar activity can increase the occurrence of lightning strikes, possibly due to changes in atmospheric electricity. It's fascinating to think that the sun's energetic outbursts might play a role in the electrifying storms we experience here on our planet. This connection between solar and terrestrial phenomena illustrates the sun's reach into our daily lives. Consider this. Solar flares can also impact the delicate balance of Earth's climate. During periods of high solar activity, the increased radiation can lead to slight warming of the Earth's atmosphere. However, this influence is complex and interwoven with other factors like volcanic activity and greenhouse gases. The sun's flares are just one thread in the intricate tapestry of our planet's climate system, reminding us of the delicate balance that sustains life. In the realm of intriguing scientific pursuits, solar flares offer a unique opportunity to study nuclear fusion. The sun is, after all, a giant nuclear reactor, and the processes occurring within it can provide insights into creating sustainable fusion energy here on Earth. By observing solar flares and the reactions that occur, scientists hope to unlock the secrets of this powerful energy source, potentially revolutionizing our approach to energy production. And here's an unexpected connection. Solar flares can impact seismic activity on Earth. Some researchers have found correlations between increased solar activity and fluctuations in the Earth's crust. While the mechanisms behind this relationship are still being explored, it's a fascinating glimpse into how solar phenomena might ripple through our planet's geological systems. Imagine this. Solar flares have even inspired art and literature throughout history, from ancient myths that personified the sun as a fiery god, to modern stories exploring cosmic wonders. The sun's flares have captured the human imagination. Artists and writers draw inspiration from the sun's radiant power, weaving its influence into narratives that bridge the gap between science and the human experience. Speaking of bridging gaps, did you know that solar flares can influence the Earth's Van Allen radiation belts? These belts, which encircle our planet, are filled with charged particles that are trapped by Earth's magnetic field. When solar flares occur, they can disrupt these belts, potentially affecting satellites and space missions. Understanding this interaction is crucial for protecting our technological infrastructure in space, a delicate dance of energy and magnetism. Here's something to ponder. Solar flares have been observed on other stars too. These stellar flares are similar in nature to those of our Sun, reminding us that the processes we observe in our solar system are part of a broader cosmic landscape. Each star has its own rhythm and energy, contributing to the vast orchestra of the universe. Consider this final thought. The study of solar flares is a testament to human curiosity and our desire to explore the unknown. From ancient astronomers gazing at sunspots to modern scientists using cutting-edge technology, our quest to understand the sun's flares reflects a timeless pursuit of knowledge. As we continue to unravel these mysteries, we are reminded of the sun's enduring influence on our lives and the universe beyond. May these insights into the sun's flares gently illuminate your journey into the realms of sleep, where dreams and stars intertwine. Let me take you on another journey through the mysterious and captivating world of solar flares and space weather. One fascinating aspect of solar flares is their ability to strip away electrons from atoms, a process known as ionization. This phenomenon can cause disturbances in radio signals, particularly those that travel long distances. Imagine how this ionization, occurring far above us, could disrupt an entire network of communication, reminding us of the sun's invisible hand in our everyday technologies. Did you know that the largest solar flare ever recorded occurred on November 4, 1960? This colossal event was so powerful that it overloaded the sensors of the instruments used to measure it. While the exact magnitude remains uncertain due to this overload, it serves as a stark reminder of the Sun's formidable power and the challenges faced by scientists in capturing the full extent of its activity. Here's an intriguing thought. Solar flares can even affect animal behavior. Some studies suggest that migratory birds, which rely on the Earth's magnetic fields for navigation, may be impacted by solar storms. These disturbances can cause birds to deviate from their intended paths, highlighting an extraordinary connection between solar activity and the natural world. It's a beautiful testament to how life on Earth is finely tuned to the rhythms of the cosmos. Speaking of rhythms, the Sun undergoes an approximately 11-year cycle known as the solar cycle, during which solar activity waxes and wanes. At the peak of this cycle, known as solar maximum, solar flares and sunspots are more frequent. Understanding this cycle helps scientists predict solar activity, providing valuable insights into potential impacts on technology and climate. It's like a celestial metronome, setting the pace for solar phenomena. And here's something quite surprising. During solar storms, the ionosphere expands, effectively increasing the drag on satellites. This added drag can affect their orbits, leading to potential re-entry into the Earth's atmosphere. Engineers must account for this when designing satellite systems, ensuring they can withstand these unpredictable shifts. It's a dance of physics that keeps our technological marvels aloft and functional. Have you ever wondered about the colors of auroras? These dazzling displays of light are a result of solar particles colliding with atmospheric gases. The colors differ based on the type of gas and altitude of interaction. Oxygen at higher altitudes produces red auroras, while nitrogen contributes blues and purples. This vibrant palette is painted by the Sun's energetic outbursts, turning our skies into natural works of art. Here's a fact that might catch you off guard. Solar flares emit radiation across the electromagnetic spectrum, including X-rays and gamma rays. These high-energy emissions can cause sudden ionospheric disturbances known as solar flares' sudden ionospheric effects. It's a reminder of the Sun's capacity to impact Earth with its energetic radiation, creating subtle yet significant influences on our planet's atmospheric layers. Consider this. The study of solar flares has led to advancements in space weather forecasting. By understanding the precursors and signatures of solar flares, scientists can better predict when and where these events might occur. This predictive ability is crucial for safeguarding astronauts, satellites, and power grids, embodying humanity's ever-growing ability to anticipate and mitigate cosmic risks. On the topic of power, did you know that intense solar flares can create geomagnetic storms capable of disrupting power grids on Earth? These storms induce currents in power lines, potentially causing transformer damage and widespread outages. The Carrington event of 1859. One of the most powerful geomagnetic storms on record, is a historical example of such disruption. It's a humbling reminder of our planet's vulnerability to solar forces. Here's something to think about. Solar flares can influence the formation of ozone in the Earth's atmosphere. During intense solar activity, increased levels of nitrogen oxides are produced, which can deplete ozone molecules. This intricate dance between solar activity and atmospheric chemistry illustrates the multifaceted ways in which solar phenomena can affect our planet's environment. Can you imagine the Sun's influence reaching beyond our solar system? Some scientists believe that solar flares could impact interstellar space weather, affecting the heliosphere a bubble-like region of space dominated by the solar wind. The heliosphere acts as a shield, protecting our solar system from cosmic rays. Understanding how solar flares interact with this boundary can enhance our comprehension of the Sun's role in the broader galaxy. Here's a captivating observation. Solar flares have been linked to changes in the Earth's magnetosphere, the region surrounding our planet dominated by its magnetic field. These changes can lead to magnetic reconnection events, where magnetic field lines break and reconnect, releasing massive amounts of energy. This process is fundamental to our understanding of how energy is transferred within space environments. Speaking of energy transfer, solar flares are often accompanied by coronal mass ejections, or CMEs, which are massive bursts of solar wind and magnetic fields. When these CMEs reach Earth, they can trigger geomagnetic storms, creating spectacular auroras and impacting technological systems. It's a dynamic interaction between the Sun and our planet, a cosmic ballet of particles and fields. Finally, solar flares are a subject of continuous scientific inquiry, with researchers using space-based observatories such as the Solar Dynamics Observatory and the Parker Solar Probe to study them. These missions aim to unravel the mysteries of solar activity, providing crucial insights that enhance our understanding of the Sun's complex behavior. The quest for knowledge about solar flares is an enduring journey, a testament to humanity's innate curiosity about the universe. As you drift into the gentle embrace of sleep, let these cosmic wonders linger in your thoughts, inviting dreams of solar winds and celestial harmonies. Imagine the vastness of space and the incredible energies at play. Did you know that solar flares can reach speeds of up to 1,000 kilometers per second? This rapid movement of charged particles can travel the distance from the Sun to Earth in just a few days, showcasing the immense power and speed of these solar phenomena. It's truly astonishing to think about how quickly these solar particles can traverse such vast distances. Speaking of speed, here's an intriguing thought. Solar flares can accelerate particles to nearly the speed of light. These high-energy particles are known as solar energetic particles, and they hold the potential to pose significant radiation hazards for astronauts and spacecraft. The ability of solar flares to propel these particles at such incredible speeds is a testament to the dynamic and powerful nature of our Sun. You might find it surprising that solar flares can also be observed on other stars. These stellar flares are similar to those on our Sun, but can be much more intense. Studying flares on distant stars helps astronomers understand the magnetic activity of other solar systems and offers insights into the potential habitability of exoplanets. It's a beautiful example of how our knowledge of the Sun informs our understanding of the broader universe. Here's a captivating fact. Solar flares can influence the ionosphere's ability to reflect radio waves. This can lead to temporary communication blackouts, affecting aviation, navigation, and emergency services. Understanding these disruptions is crucial for maintaining reliable communication channels in an increasingly connected world. It's a reminder of the Sun's far-reaching impact on our technological infrastructure. Now, consider this. The energy released by a solar flare can be equivalent to millions of atomic bombs exploding simultaneously. This staggering release of energy is a demonstration of the Sun's immense power, capable of affecting both space weather and terrestrial conditions. It's a humbling reminder of the forces at play beyond our planet's atmosphere. Speaking of energy, solar flares often originate from sunspots, which are cooler, darker areas on the Sun's surface. These sunspots are indicators of intense magnetic activity, and their presence often signals an increase in solar flare occurrences. Observing sunspots allows scientists to predict periods of heightened solar activity, contributing to our ability to anticipate space weather events. Did you know that solar flares can also create temporary holes in the ozone layer? During intense solar activity, energetic particles can penetrate the Earth's atmosphere, leading to chemical reactions that deplete ozone molecules. This intricate interaction between solar flares and the ozone layer highlights the complex ways in which space weather can influence our planet's environment. Here's a fact that might surprise you. The sun's magnetic field is continuously changing, and solar flares play a role in this dynamic process. The sun's magnetic polarity flips approximately every 11 years, coinciding with the solar cycle. Understanding these magnetic shifts helps scientists study the sun's behavior and its impact on the solar system, providing insights into the fundamental workings of our closest star. And here's something remarkable. Solar flares can contribute to the creation of cosmic rays. These high-energy particles travel through space and can even reach the Earth's surface, where they interact with our atmosphere. The study of cosmic rays offers valuable information about the sun's influence on space weather and the processes occurring beyond our solar system. Speaking of cosmic phenomena, solar flares have been observed to occur in clusters, often accompanied by other energetic solar events such as coronal mass ejections. This clustering of activity is a fascinating aspect of solar weather, revealing the interconnectedness of various solar processes. It's a reminder of the sun's dynamic and unpredictable nature. Here's an interesting tidbit. The study of solar flares has led to the development of advanced computer models used to simulate their behavior. These models help scientists predict the potential impact of solar flares on Earth's environment and technology. This predictive capability is crucial for safeguarding our planet against the disruptive effects of space weather. Imagine this. Some solar flares are powerful enough to create disturbances in the Earth's magnetosphere that can be detected by seismometers, instruments used to measure ground motion. These solar-induced tremors illustrate the profound ways in which solar activity can influence terrestrial systems, blurring the boundaries between space and Earth. Here's something to ponder. Solar flares can produce ultraviolet and X-ray emissions that increase the ionization of the Earth's upper atmosphere. This increased ionization can enhance the performance of radio communication systems at certain frequencies, offering unexpected benefits amidst the challenges posed by space weather. Finally, consider the legacy of solar flare research. Over the years, scientists have developed a detailed understanding of solar activity, allowing for the creation of space weather forecasting systems. These systems are critical for protecting astronauts, satellites, and power grids, embodying our growing ability to anticipate and mitigate cosmic risks. As you drift into a restful sleep, let the wonders of solar flares and space weather fill your dreams. The sun, with its powerful and mysterious presence, continues to inspire awe and curiosity in the hearts of those who gaze upon its radiant glow. May your night be filled with thoughts of celestial wonders and the enchanting dance of particles and light. Our journey through the cosmos continues with yet another fascinating detail about solar flares. They can cause geomagnetic storms that occasionally produce beautiful auroras. These shimmering lights, seen near the polar regions, are the result of charged particles interacting with the Earth's magnetic field. The spectacle is not just visually stunning, but also a testament to the sun's reach, creating natural light shows far from its blazing surface. Let me share another thought that might intrigue you. Solar flares have the power to heat the sun's corona to tens of millions of degrees Celsius, much hotter than the sun's surface itself. This intense heat is a source of curiosity for scientists, as it plays a crucial role in driving the solar wind, the stream of charged particles that flows outward through the solar system. It's a reminder of the sun's complex inner workings which continue to puzzle and inspire. Speaking of the solar wind, did you know that its interactions with the Earth's magnetic field can lead to fluctuations in the power grid? These fluctuations, known as geomagnetically induced currents, can potentially disrupt electrical systems, highlighting the importance of monitoring space weather to protect critical infrastructure on Earth. Our interconnected world relies on a deeper understanding of these solar influences to maintain stability and security. Here's something to ponder. The sun emits more than just visible light during a solar flare. It also produces radio waves that can travel vast distances across the solar system. These radio emissions provide valuable data for scientists, helping them to study the flare's characteristics and their potential effects on space weather. The versatility of solar emissions underscores the sun's role as a cosmic broadcaster, sending signals that can be picked up by distant observers. And did you know that solar flares can sometimes trigger magnificent solar tsunamis on the sun's surface? These colossal waves of hot plasma can rise several kilometers high and travel at speeds exceeding 400 kilometers per second. Observing these solar tsunamis helps scientists understand the dynamics of the sun's atmosphere and the forces that shape its ever-changing landscape. Let's explore another captivating fact. Occasionally, solar flares can enhance the natural radioactivity of our atmosphere. This occurs when high-energy particles collide with atmospheric molecules, creating isotopes like carbon-14, which are valuable for radiocarbon dating archaeological and geological samples. This unexpected intersection of cosmic and earthly phenomena highlights the sun's subtle influence on our planet's history. Another surprising insight involves the potential link between solar flares and lightning storms on Earth. Some researchers suggest that solar activity may modulate the frequency and intensity of lightning bolts, adding a cosmic dimension to this terrestrial weather phenomenon. While the exact mechanisms remain a topic of investigation, it's a reminder of the interconnectedness between space weather and earthly events. A lesser-known but intriguing consequence of solar flares is their potential impact on animal navigation. Some studies suggest that certain species, like birds and sea turtles which rely on Earth's magnetic field for migration, might experience disorientation during intense solar activity. This subtle influence on the natural world is yet another way the sun's dynamic energy finds its way into our everyday lives. Here's a thought-provoking tidbit. Solar flares can influence the space weather environment around other planets too. For instance, intense solar activity can create auroras on planets like Jupiter and Saturn, offering a glimpse into the magnetic interactions at play in these distant worlds. The study of these planetary auroras provides valuable insights into the magnetic environments of other celestial bodies and enriches our understanding of the solar system. Consider this. The study of solar flares has led to technological advancements that improve our ability to monitor and predict space weather. Instruments like solar observatories and satellites equipped with specialized sensors allow scientists to observe solar activity in real time, enhancing our preparedness for solar storms. This technological leap forward is a testament to human ingenuity and our quest to understand the universe. And here's something to inspire your sense of wonder. The sun, through its flares and other phenomena, serves as a natural laboratory for studying plasma physics. The insights gained from observing solar activity have applications far beyond our solar system, informing research on fusion energy and other cutting-edge scientific endeavors, the Sun, as our nearest star, remains a source of inspiration and knowledge, lighting the way for future discoveries. As we wrap up this exploration of solar flares, contemplate the vastness of space weather's influence, from the dazzling auroras to the subtle shifts in atmospheric chemistry. The effects of solar activity are woven into the fabric of our existence. They remind us of our place in the cosmos, a tiny blue dot orbiting an immense ball of fire, whose fluctuations shape our world in unexpected ways. May the mysteries of the Sun continue to spark your curiosity. These insights into solar flares and space weather are a testament to the interconnectedness of all things, from the smallest isotopes to the grandest auroras. As the sun sets on this chapter, let your thoughts drift through the universe, filled with the wonder of what lies beyond. And so we gently continue our cosmic journey. Did you know that solar flares can sometimes send showers of high-energy particles known as solar energetic particles rushing through space? These particles travel at incredible speeds and can reach Earth in less than an hour, demonstrating the rapidity with which space weather can change. This swift journey of particles showcases the Sun's ability to influence our planet in an almost instant connection across the vastness of space. Here's something else to marvel at. During intense periods of solar activity, the Sun can release giant clouds of plasma called coronal mass ejections. These powerful ejections can carry billions of tons of solar material and have the potential to affect the entire solar system. They remind us of the scale of the forces at play in our solar neighborhood and the remarkable capacity of our Sun to shape its surroundings. Speaking of powerful forces, consider this. Some solar flares are accompanied by a phenomenon known as a magnetohydrodynamic wave. These waves propagate through the Sun's atmosphere, carrying information about the solar flare's energy and the Sun's magnetic field. Observing these waves helps scientists unravel the complexities of the Sun's magnetic environment, offering a glimpse into the invisible forces that govern solar activity. Have you ever wondered about the Sun's impact on space exploration? During periods of heightened solar activity, increased radiation levels in space can pose a significant risk to astronauts. This potential danger is why space agencies closely monitor solar weather to ensure the safety of human spaceflight. It's a reminder of how our quest to explore beyond our planet must always account for the powerful forces emanating from our nearest star. Here's a thought-provoking tidbit. Solar flares have the fascinating ability to affect the ionization levels in Earth's upper atmosphere. These changes can disrupt radio communications, particularly over the polar regions, illustrating the Sun's direct influence on our planet's communication systems. This interaction with the ionosphere highlights the delicate interplay between solar activity and technology we often take for granted. Another captivating fact lies in the Sun's influence on climate. While solar flares themselves do not directly cause long-term climate change, variations in solar activity over centuries, known as solar cycles, can have subtle effects on Earth's climate systems. The study of these cycles helps scientists understand natural climate variability, contributing to a broader understanding of how our planet responds to changes in solar energy. Let me share another interesting aspect. The Sun's activity does not only affect planets, but can also have an impact on comets. As comets travel through the solar system, solar flares and the solar wind can alter their tails, causing them to shift and dance in the cosmic breeze. This celestial ballet of comet tails provides a visual testament to the dynamic relationship between the Sun and other celestial bodies. And did you know that solar flares can influence the behavior of satellites orbiting Earth? During intense solar activity, increased radiation can lead to charging of satellite surfaces, potentially causing malfunctions or damage. These effects underscore the need for robust satellite design and vigilant monitoring of space weather to safeguard our space-based technologies. Here's something else to consider. The study of solar flares has inspired scientists to develop sophisticated models to predict space weather. By understanding the mechanisms behind solar activity, researchers can improve forecasts of solar storms and their potential impacts on Earth, enhancing our ability to prepare for and mitigate the effects of these cosmic events. Reflect for a moment on the sheer energy of a solar flare. Some flares release energy equivalent to billions of atomic bombs exploding simultaneously. This staggering release of energy is a testament to the immense power contained within the sun's magnetic fields, and it serves as a humbling reminder of the forces that drive our solar system. Have you ever thought about the sun's effects on other stars? Observations of solar flares have shed light on similar phenomena occurring on other stars known as stellar flares. These events provide a window into the behavior of stars across the universe, highlighting the commonalities in stellar processes that extend far beyond our own sun. Here's a fascinating insight. The auroras created by solar flares and the solar wind are not just beautiful. They also tell a story about the sun's magnetic field. By studying the colors and patterns of the auroras, scientists can gain insights into the structure and dynamics of the magnetic fields that connect Earth to the sun. And let's not forget the role of solar flares in advancing our understanding of nuclear physics. The intense heat and pressure created during a flare mimic conditions found in nuclear fusion, offering a natural laboratory for studying these processes. This knowledge has applications in developing fusion energy, a potential clean energy source for the future. As we draw near the end of our cosmic exploration, consider the interconnectedness of all these phenomena. Solar flares and space weather not only shape our understanding of the sun, but also illuminate the complex web of interactions that link the stars, planets, and other celestial bodies. Each burst of solar energy is a reminder of the sun's dynamic nature and its ever-present influence on our universe. May you carry these wonders with you, even as you drift into a peaceful slumber, knowing that the sun's story continues to unfold in the vastness of space, a timeless narrative of energy and light that reaches out across the cosmos.